Let's jump right into this explainer. If you've been following the Nemori River memory architecture, you know the docks are absolutely dripping with beautiful poetic biology. Watersheds, firing axons, hippocampal bindings. It sounds almost alive, right? Well, today we're grabbing our whiteboard markers and stripping all of that away. We are tracing the literal, hard-coded life cycle of this system to reveal the raw Python logic, the strict integers, and the incredibly clever structural choices underneath the metaphor.
Here's our architectural roadmap for today. We're going from raw packets to distilled facts, looking at the three-gate logic and boundaries, diving into the memevolve bridge and surprisal triggers, checking out co-occurrence and strategic memory, decoding those river metaphors, and finally, looking at the protocols for library extraction.
All right, let's kick things off with Section 1, Raw Packets to Distilled Facts. We're starting at the absolute beginning of the data pipeline. How does a continuous, messy stream actually become a structured node in our memory graph? Well, the system ingests either free-form unstructured text or agent execution trajectories. From there, it chunks that chaos into discrete 50-token packets inside the quantization layer. Next, it builds a development episode around those chunks, applying a dominant archetype and a central theme via hierarchical clustering. Finally, we hit the hop-field basin distillation phase. It predicts what facts should exist, compares them against the logs to find the new stuff, and distills them into graffiti fact nodes with provenance backlinks. It is a rigorous transformation from absolute chaos to crystal clear structure.
And right here is where we see our first massive collision between narrative and actual code. On the left, the documentation sells you this organic neural axon turning continuous voltage into discrete spikes. But on the right, the reality is just a highly efficient quantization layer executing basic arithmetic. It explicitly splits content into exactly 50 token chunks. Even the spike duration is just a simple math heuristic, 50 plus the token count times 10. There's no biological simulation happening here, guys, just remarkably elegant accounting.
Moving right along to Section 2, Three-Gate Logic and Boundaries.
So, as these 50-token packets flow down the river, they hit our first major structural threshold, the boundary detectors. How does the system know when one event ends and another begins? It uses this brilliant three-gate logic matrix. First up, the SEM gate checks if the structured event memory probability is at least 0.5, using really fast SHA-256 hashed surrogates, so no expensive semantic embeddings here. If that doesn't trip, it checks if the maximum surprisal over the events is greater than 0.8. Finally, it looks for a dissonant resonance mode or a turbulent mode combined with a surprisal over 0.6. It runs these checks strictly in this order.
But here's the absolute kicker. If no gates trip, the function deterministically returns false. Why is that such a game changer? Because previously, this system used a heavy LLM prompt to check boundaries. By swapping that out for this hard-coded sequential logic, the system completely prevents redundant processing. We're talking about saving roughly 600 tokens every single time this check runs. At scale, enforcing that strict token economy is just a massive optimization.
Let's slide into Section 3, memevolve bridge and surprisal triggers.
Okay, we know how boundaries work, but what happens when the engine encounters something genuinely unexpected? Enter the magic number, 0.6. This exact float value is the system's hard-coded inciting incident. You see, in Nemori, surprisal isn't just a vague feeling, it is literally a system-wide currency. And when that currency spikes above 0.6, the entire architecture wakes up.
Crossing that 0.6 threshold instantly fires off these massive side effects. It updates the arousal cache. It signals dissonance to the Hexus service. But crucially, it activates the meta-evolution trigger, memevolve bridge B. It takes the episode, wraps it up in trajectory data, slaps a memskill.hard_case metadata label on it, and shoves it right across the bridge into the memevolve engine for diagnosis and tournament selection. This is literally how the system recognizes its own gaps and physically triggers its own evolution. Now, you might be thinking, if the system constantly feeds memories out to other systems and then evolves based on them, couldn't it get stuck in an infinite loop? Absolutely, and that's exactly why Cascade Guard exists. It's our unsung hero here. Whenever facts are emitted, they get tagged with a specific memory type label, sourceorigin.nemori_distill. Cascade Guard intercepts this label on ingestion and instantly blocks reverse direction data loops, keeping the system from accidentally eating its own tail.
On to Section 4, Co-occurrence and Strategic Memory. Beyond just reacting to the unexpected, the river is always hunting for recurring themes to promote into long-term strategic memory. We had 0.6 earlier, but here's another hard-coded favorite, the integer 3. This specific number is the exact co-occurrence threshold needed to promote a memory.
So, forget the poetic idea of emergent strategy detection. What's actually sitting in the Python file is a super aggressive, precise token matching rule. The code tokenizes each fact, checks for word-level matches against existing facts, and the second that match count hits exactly 3, it automatically persists the data to strategic memory via the Hexis memory service. It's not a sentient realization, it's just a flawlessly executed greater than or equal to 3 conditional statement.
All right, Section 5. Decoding the river metaphors. Time to pull out the red marker.
Let's separate the narrative myths from the compiled reality, starting with hippocampal binding, the biological replay model before consolidation, pure narrative design. The reality is just a really clever secondary LLM pass. The code literally just makes an extra LLM call with a system prompt that says, "You are a hippocampal architect," asking it to rewrite the episode narrative to sharpen entity bindings and active goals. No organic consolidation, just a wonderfully named prompt.
Or how about the 12 Jungian archetypes used to cluster episodes? While the LLM prompt does restrict its output to those 12 primary archetypes, the actual code enum quietly supports 24 total states. For every primary archetype, there's an explicit shadow complement mapped to it, like innocent mapping to naive. This lets the system track deep narrative shadows entirely independently of the episode generation prompt.
And the river itself? We picture water flowing perfectly downstream from source to tributary to main river to delta. Gorgeous design intent, right? But structurally, there is absolutely zero fluid dynamic simulation. There isn't even runtime monotonicity enforcement. The code just assigns default enum values to data classes. Events get a source tag. Episodes get a tributary tag. There's literally nothing stopping data from bypassing everything and jumping straight to the delta.
Finally, let's wrap up with Section 6. Protocols for library extraction. If we look at the future of this codebase through track 651, we see this massive engine preparing to be extracted into a standalone library. The latest commits lay out these precise protocol schemes. They're enforcing a clean Apache 2.0 open-source license posture. They're defining clear interfaces, basin backend for alone-back storage routing, memory store for episodic graffiti persistence, and an event bus for narrative pub sub-subscriptions. The architecture is maturing from a tightly coupled monolith into a highly modular, testable pipeline.
So, as we step back from the whiteboard today, look at what we've uncovered. We stripped away the biological watershed, the hippocampal replays, and the organic axons, and found incredibly efficient token economies, strict float thresholds, and elegant enum classes. Which leaves us with a pretty fascinating question. Is the future of system architecture driven by better code or by better metaphors? Was it the strict Python logic or the rich biological narrative that actually allowed the engineers to conceptualize something this complex in the first place? Think about that as you design your own systems. Thanks for hanging out with me for this explainer, and I'll see you next time.